Jai Hind everyone. I Rupak Kumar from Akgec. Today we come to know the database management system, that is BCS 501 subject, in which we already discussed the ER diagram in last lecture. Today we discuss the extended ER diagram, ER model, in which when we start knowing about the how we create a ER diagram, and after that if we got some problem and something we are just stuck in a ER diagram, then we need the extended ER diagram. That is what in extended ER diagram we talk about. First of all, what is extended ER diagram? That is extended entity relationship features. So first we come to know what is the features of extended entity relationship. So as the complexity of data increase, means when we are using ER diagram before 1980s, we just see that complexity of data is increased, and that it becomes more and more difficult to use the traditional ER model for database modeling. So hence we say, then we are just come to know it becomes more difficulties for us to complete the ER diagram with some error, with some difficulties. So hence some improvement is need, and then for that improvement we just enhance that we are made to the existing ER model to make it able to handle the complex application better. Means when we are using ER diagram, means ER diagram is basically a basic requirement while we are going to create a database. We are just creating the database for our organization, for our some university, some college purpose. And when we are just creating the ER diagram, then we are just getting some problem. When we are just deal with some complex application, then we are just facing the problem, and that problem is that we just added the some extended things in that ER model. That is what in entity relationship around 1980s, and that is basically good to handle the data from that. It is a very complex application. When it contains a complex application, then we need some extra extended things to complete our process. So hence, as a part of extended ER model, along with other improvement, we are just going to add some new concept. We added some new concept were added for existing ER model. We are already using some ER models, but as we are just not able to solve some complex in that in that model, when we are creating some ER diagram for a database, then we see there is some complexity, and for solving this complexity we just use three things inside that, three new concept that were added to existing ER model. ER model is basically that is what existing. We are just using that ER model, but we add some features, and that features is basically known as the first features is your generalization. This is what the new concept that is were not added before 1980s. It is added after 1980s in a ER model to solve the complex problem. Next, we can say next new concept is your specialization. It is not added before 1980 in a ER model. It is also a new concept that were added to existing ER models. And third one, the third new concept which is added, that is what? Aggregation. Generalization, specialization, and aggregation. This is what the three new concepts that were added to existing ER model to improve our entity relationship diagram, which were an existing ER models. So we just see what the change is that. Then with the help of these three new concepts, we are just now able to solve some complex applications problems which we were just finding while we creating a database, for some organization and all. Now after adding these features, we just try to solve the problem, try to solve the complex problem inside creating any database. So we can see that this is what the three new feature which just solve our complex application which were not solved on or before 1980s. After adding these three features, generalization, specialization, and aggregation, we just try to solve the complex problem from that. Clear? Next, first of all, we just come to know what is generalization, how we proceed with the generalization. So we can say the generalization is basically the process for extracting common properties. We just extract some common properties from a set of entities. We are just using many entities inside a ER diagram as we required. It is not fixed that we were 5 entities for library management system or banking system. It is not fixed. It's all depends on the requirement of organization. It's all depend the requirement of end user. That is what we can say. If in a generalization process we just extracting the common properties from a set of entities and create a generalized entity from it, means we take the something from existing entities and just generalize them in a some other entity. That generalized form is called as generalization. So we can say what we do, it's basically from bottom up approach. Why it is bottom up approach? We can say generalization is the bottom up approach in which we just in that generalization what we do, in which we just two or more entities can be combined. What we do in from existing entity of the ER diagram, we just take two or more entities from a that ER models, and then from a higher level entities, and if we form that higher level entity from that, and they have some attributes in a common, means what we take, we just take some entity from that existing entities and just combine to form a higher level. We just create an higher level entity, and these higher level entity is basically come while we generalize the things. That is what generalization. So we start from the bottom level, we start from the bottom entities and generalize them to create a higher level entities. What we do, we just creating a we just take the two entities from existing ER model and just create a higher level entities. This is what the higher level entities, and this is what the some entities, and we just take it something from this, some properties, means attributes of this is taken from this and this only. This is also this, they have also some attributes, and their attribute from this is common for this. So generalization basically it is start from bottom side and goes up. That's why it is called a bottom up approach, in which we can say two or more entities, and we can take two entities or we can take more than two entities also. It is not necessary we are just adding two. It's just more than one, means 2, 3 or 4, as much as we required. We can add the features to a higher level entities, and this is called a generalization process. So this is what we can see. While we generalize the things, it is from lower level to higher level. So we generalize the things as we required. So we can say generalization is basically a bottom up approach in which two or more entity can combine to form a higher level entity, and if they have some attribute in commons. That is what we can say. It is also called as a subclass that is combined to make a superclass. Means what we combine from lower level, that is called a subclasses, is combined to create or make a superclass. So this is what the concepts of super and subclasses in generalization. So if you say generalization is used to emphasize the similarities among the lower level entities, means what is the similarities among the lower level, or we can say subclass, that is what we can say a set, and that hidden difference in that we can say in the schemas. So this is what how we generalize the things, how generalization is used. So generalization is used to emphasize the similarities among the lower level entity set and hide difference in that schema. That is what it is not shown in that. What is the similarities is there. So we can see here how generalization is done with the help of lower level entity. So we can find that here is the entity 1 and entity 2. So we just take some features from both entity and create an entity 3. So this is what we can say, it is a subclass. It is also a subclass, and this is what the superclass. So these two subclass is generalized. This is what the symbols of generalization. These two class is generalized to create a superclass. That's what entity 1, entity 2 is generalized to make a entity 3 as a superclass. Or we can say it is a bottom up approach. We start from lower level and goes to the upper level. This is what the bottom up approach. It is nothing but a bottom up approach. So what the generalization do? Generalization is basically taking some attributes from entity and sub attribute from other entity and combine it or generalize it to create a new entity or higher level entity, and the attributes from these are taken inside these new superclass entities. So this is what generalization. So we can say generalization is the process of extracting a common property from set of entity and create a generalized entity from it. Clear? So this is what how we can define the generalization in general. Next. Generalization is the process basically of extracting the common property, and that is what extracting, or it is shown in figure that it is a bottom up approach. We just start from bottom, combining the things from bottom and goes up upper layer, upper level, and this is what the symbols of generalization only. Here when we generalize the things from lower entity to upper entity, this is what we can upgrade that. This is what the subclass, this is what a superclass. Clear? Now we can take an example where we generalize the thing. Here is an example of basically taken from ER diagram of banking system. Here we just take two entities, that is saving account and current account. These two, saving account and current account, basically is a relationship with an account. Means saving account is a generalized form of account, is a generalized form of saving account and current account. It is a subclass, and it is a superclass. This is what we are going from lower level entity to upper level. That's why it's a bottom up approach. So in a banking system, we have an account. That account have an entities like account number, that is account number from saving, account number from current account. It has also account number. It has also a customer ID. It has also a customer ID. This is what thing we are just, it is related with a relationship, and that relationship in a generalization is called is a relationship. Means we can say saving account is a account, current account is a account. These both are combinedly is account. So generalization is the process of extracting common property from set of entities and create a generalized entity from it. This is what we can say a generalization process by taking an example. So it is clear how we proceed with the generalization. Next is your we can take another example for generalized purpose more than two entities. So consider we consider we have a three sub entities like car, bus, motorcycle. Now what we do, we just combine these three entity and can generalize it into a higher level entity or a superclass named as vehicles. Means car is a vehicle, bus is a vehicle, motorcycle is a vehicle. So these all subclass of vehicles is basically related with a generalization process. So car is generalized, bus is generalized, and motorcycle is generalized as a vehicle. So a common property from these vehicles are taken from this superclass to subclass. This is what we can say, we just take the sub property from car and put it in a vehicles properties, bus and motorcycle. So this is a relationship with vehicles and superclass. This is what the superclass of vehicles. This is what the subclass of a vehicle. Superclass and subclass of the vehicles. So what we do? It is a generalization process, and it is basically bottom up approach process. This is another example we can see, and now it is very clear to us that what is the generalization process. Clear? Next is your specialization. So we can say there is three features while we study the extended ER model. So we have a specialization, the second special process while we generalize the things. That is what in a specialization it is. We can say a specialization is an entity, or we can say an entity that is what divided into sub entity based on their characteristics, and it is a top down approach where higher level entity is specialized into two or more lower level entity. As we see according to the definitions of this specialization, it is nothing but a opposite of generalization. We generalize the thing, we specialize the thing. Likewise, we can say in same example we can take, suppose employee is a tester also, employee is a developer also, employee is a coder also. We can add more entity like that, na? Employee is a designer also. So we can add as much as entity we want. So as a definitions of a specialization, we can say a specialization basically in a specialization we have an entity is divided into sub entities. Means a superclass is divided into subclass. So we divide the superclass of employee into 4 subclass. So best how we divide that based on their characteristics. Employee who is doing the tester work, so it is that subclass of tester. The employee who is developer, so it is the subclass as a developer. So it is basically we start from top. It's a top down approaches, or where the higher level entity in a specialization into two or more lower level. It is a top down. Start from top. It is just basically top down approaches. Clear? So this is what the opposite of generalization. So as a definition we can see specialization is a opposite of generalization. So in specialization, an entity is broken down into sub entity and based on their characteristics. So specialization is a top down approaches where higher level entity is specialized into two or more lower level entity. It is just opposite, we can say, something is a relationship also for a generalization, and is a relationship also for a bottom up approaches, that top down approaches, that is for specialization. So specialization is used to identify the subset of an entity set and that shares some distinguished characteristics. So specialization, if we talk about specialization can be rapidly applied to refine the design of a schema, where we have to refine the things in a ER diagram. Then we just use the specialization, and that with the help of that specialization we just refine the design of a schema, and we can say it is with the help of is a relationship. So the area also we can see it is a relationship in this employee and special employee. This is what is a relationship between this. This is what we can say specialization is basically is a relationship also. It is also generalization is also is a relationship, and specialization is also is a relationship. So here we can take an example of specialization. We can see how it is a top down approaches, and we can see what is the common attributes among them. We have a employee name, we have a salary, we have an employee ID. Likewise, when we take this superclass to a subclass, that tester and a developer, we can have these entity is added in that. Except this, we can have a different entity also, like test type. Test type is basically some other entity for this. This is for the developers types. So we can add more entity inside that subclass. So it is a top down approaches. It is a relationship between the these entities of ER model. So this is what a special feature which we added to make it extended. Here we can see in an example of vehicle. Vehicles is entity that can be a car, can be a truck, or can be a motorcycle. So this is what is a relationship. Normally the superclass is defined first, and then subclass is a related attributes among defining that next. So and the relationship set are then added. So we have a superclass like vehicles, and vehicle is a car, vehicle is a bus, vehicle is a motorcycle. This is what the top down approach is from upper level superclass, and just go to the lower level. And attribute is also common among that, vehicles number, chassis number, and model number. These are all special things we can add it inside this specialization. So this is what we can say. Next is your how we see in a common diagram. This is what the common diagram of generalization and specialization. Here vehicle is a relationship with bus, car, and motorcycle. So this is the relationship is common with both as a specialization and generalization. So we can see in this diagram, vehicle is a car is a specialization of vehicles. This we can say, so there is some attribute, make, model, and chassis. This is what the same for all. Here is also making attributes, model, and chassis attributes. Bus is also have a make, model, and chassis. Bus seat present in that, this is different. Seat number in bus is different. Motorcycle load capacity is different. But the common things is common attribute is common to all. So here we can just compare the things, generalization and specialization. So we can see it is nothing. It is basically opposite of it is opposite of each other. Means it is basically a top down approach, a bottom up approach, and this is what the top down approach. Start from top to down, it is start from bottom to up. So generalize the things, car, bus, and motorcycle to vehicles, and vehicle is specialized as a car, bus, and a motorcycle. This is what the two different things inside that. Here is also, suppose we can have a imply. Imply is basically generalized, specialized as a officers, tailor, and security. We can have a extra added to features for this. And imply is also a person, and person is specialized as a employee, as a customer, as a all. So this is what we can see a very good example of generalization and specialization. This is what we can have. Start from top level, a person is an employee, an employee is a teller, employee is a security. What we can just go from upper to upper level, that is person, to generalize specialize the things as a person is specialized as a security or tailor or officer. We can say these all officer, tailor is generalized as a person, generalized as a employee. Both things is there. We can write here also. So this is what the best example where we can just understand the things, generalization and specialization very clearly. Okay. Anything that is what not understand with this is not possible. I think it's very clear to all. Now, next, how schema and tables can be formed with the help of these diagram. So we can see here we have a customer. Customer, we can have an entity like customer, have attribute name, street, city, credit, and rating. These are the attributes of the customer. Customers, we can write the attribute here. Likewise, officers, they have also name, street, city, salary, and one of the entity attributes of entity is maybe different. Like if I can talk about the tailor, the sum of the entity is common, and something what that is hours of working and all is different attributes from this. Likewise, the secretary, that is what name, street, city, salary, and house. That is what how we can uh, create these as a tables form. So this is what the tables of every entity inside this. So this is what the secretary table, tailor table, officer tables, employee, customers, and person tables can be created inside that. There must be one of the attributes may be different from all these. That is what hours worked, that is what hours worked, and we can say station number and officer number. So this is what the secretary's work are there. Next is your aggregation. So aggregation is what it is used when we need to extend a relationship among the relationship. So it is what it is a relationship among relationship. So we can say aggregation is basically abstract through which relationship are treated as a higher level entities. So aggregation is the process when a relationship between two entities is considered as a single entity, and again the single entity has a relationship with another entity. These are the relationship among relationship. So these we can see with the help of these, we can say eliminate this redundancy via aggregation. Means how we what we do with the help of aggregation, we just treat the relationship as an abstract entity. We just allow the relationship between the relationship, we just abstraction of a relationship into a new entity. So this is what we can do with the help of aggregation. Here we can understand the aggregation. Aggregation is basically abstraction through which we can represent the relationship as a higher level entity set. So likewise, coaching center offers the courses. This is what one of the aggregation relationship. It is what the abstract through which we can represent a relationship. Means it's basically a higher level entity. So here we can see aggregation. So aggregation is basically coaching center offers the courses, and that relationship of offers is basically inquired by the visitors. So visitor inquire offers for courses, you know, visitors inquires offers for coaching center. This is what how aggregation is related with each other. So here we can take an example of aggregation. With aggregation without introducing the redundancy, so ER diagram can be represented as an employee works on a particular jobs as at a particular branch. So that is what employee works on relationship. They are related with works on relationship with a particular branch. That is what we can say employee branch job and combinations may have a associated manager. Means they are looking by the managers, and manager is managing by the manager manage the works on with branch and employee and all. So this ER diagram show the aggregation relationship. So aggregation, we can see how these they are all related. Means manager manage the works on branch, that is what employee works on that branch, job is for employee works on branch. These show the aggregation relationship inside that. This is all about the three features of extended ER diagram. We just cleared today the aggregation, specialization, and generalization. Generalization, specialization is the opposite, and aggregation is the some other feature. So these three features are added inside the ER diagram to create it as solve the complex problem. Okay, then thank you.